Hi students, I'm your Yashwant sir and I'm teaching you simple harmonic motion. So in today's class we are going to teach about simple harmonic motion. So let us discuss what is simple harmonic motion, how the equations will be formed, how the analysis will be done on the simple harmonic motion. These all things we are going to study in today's class. So let us start this class. So I am sharing the screen with you people. So this is So I am writing here simple harmonic motion. Simple harmonic motion. So now what is simple harmonic motion? If someone asks you what is simple harmonic motion, then what you can say? Simple harmonic motion is something in which a body performs motion about a fixed point. So let us discuss simple harmonic motion here. We can call it as SHM. If a body moves about a fixed point, moves about a fixed point, in to and fro motion, in to and fro motion. To and fro motion means towards and away from the point. So let us discuss with an example here. Let's call this one as a simple pendulum. Let's call this one as the simple pendulum. Now this simple pendulum will move away. This will go here, and this can also go here. So see beta, it always moves about a fixed point. In this, the fixed point is nothing but this one. So this is nothing but fixed point. This is nothing but fixed point. That means it is going away, then it is coming towards, again it is going away, and again it is coming towards. This type of motion, we termed it as simple harmonic motion. Understood, I think so. So this is what simple harmonic motion is. So the best example of simple harmonic motion is simple pendulum. Pendulum is one of the example of simple harmonic motion. So in this, there are few terminologies which we are going to discuss now. But this one is known as mean position. What is mean position is nothing but if mean position, mean position, if f net, if f net, that means force net is equal to 0 at a particular place, at a position, we call it as simple harmonic motion. We call it as mean position. We call it as mean position. That means we can't say directly that we can't say when f net is equal to 0, it does not mean velocity is equal to 0. F net is equal to 0 means acceleration is only 0, but not mere velocity. So at a particular position, if I say f net is equal to 0, that is called as mean position. Always from the starting point, always the starting point will be nothing but mean position. So this is something called as mean position, and here f net is going to be 0. F net is equal to 0. So this position is known as mean position. So now let us discuss the basic equation. Sir, if body is moving in this direction, If a body is moving in this direction, then force is acting in this direction. If displacement is in this direction, force is in this direction. That means what we can say from this one is F directly proportional to minus x. Actually, x power n you can take. Why? Because it is not directly proportional to x power 1. It can be x square, x cube, x power 5 and so on. But why? And n cannot be even, n can be only odd. All these things we will discuss. But let us give something like f directly proportional to minus x whole power n. That means f is equal to, when you remove proportionality, then you should introduce a constant. So minus kx power n. So k is nothing but simple harmonic constant. Harmonic constant. And n cannot be even, n can be only odd. N can be only odd. Why, sir? N can be only odd. Why? Because, see, if I am talking about a simple harmonic motion, if I am talking the body is at mean position, if a body is moving in this direction, then force displacement is in this direction, then force is what? Negative. So if x is positive, then force is negative. In the same way, if x is negative, then force will be positive. This condition should be obtained. For suppose if I am taking x, n is equal to 2, then f is equal to minus of kx square. So if I am taking x as positive, then I will obtain minus kx square. Okay, it is valid up to here. But if I am taking x as negative, minus of x square, then I am getting again f as minus of kx square. That means if I am taking even x as negative, then I am getting force as negative, which cannot be the condition of simple harmonic motion. The condition of simple harmonic motion is the displacement and force should be always in the opposite direction. If body is moving in this direction, then force should act in this direction. And if body is moving in this direction, then force should act in this direction. So I always say that force and displacement are always in the opposite direction. That is the minimum condition of simple harmonic motion. So that's why we can't take n as even. So n can be only taken as odd. So now in this case, what I am doing is I am talking about a very simple motion. I'm not talking about complex motion. Simple means when I'm taking n is equal to 1. So n is equal to 1 if I am taking, then I will get f dash is equal to minus of kx power 1, so which is nothing but minus of kx. So f is equal to minus of kx is the basic equation of simple harmonic motion. This is the basic equation of SHM. Now there will be some questions like f is equal to, there is a question which I have asked many times in the NEET, f is equal to minus 2x plus 2. Find whether the given equation is, find the given equation is SHM or not. Given equation is valid, equation is valid for SHM or not. So now how you can say it? Now what you will do is, first of all, for finding whether the given equation is SHM or not, what you should do is, you should take Fnet is equal to 0. So if you do Fnet is equal to 0, from that you can get a mean position. And rightward to mean position, if I am moving, then force should be obtained as negative. And if I am moving in the left direction, then force should be obtained as positive. So the main thing is, first of all, we can find mean position. Once after finding mean position, then I will go on the right side. If I am going on the right side, then force should be obtained as negative. And in the same way, if I am moving in the leftward, then force should be obtained as So let us go with the things. Finding mean position, how we can do. F net is equal to 0, that means minus 2x minus plus 2. So this means 2x minus 2x is equal to minus 2. So x is equal to simply 1. So x is equal to 1 is my mean position. X is equal to 1 is my mean position. Now if I am taking the table, so see here x is equal to 1 is my mean position. This is my mean position. Then in this direction x is equal to 2 will be there. In this direction x is equal to 0 will be there. Because rightward if I am moving 1, 2, 3, 4 and so on. That means if I am moving in this direction, then 4 should be obtained as negative. And 0, minus 1, minus 2 and so on. If I am moving in this direction, then 4 should be obtained as positive. So this is the funda which I am taking into consideration and moving on. So if I am substituting x is equal to 2, then what will happen? F is equal to minus 2 into 2 plus 2. So minus 4 plus 2, which is nothing but minus 2, valid. If I am taking x is equal to 0, minus 2 into 0 plus 2. So it will be again 2. So if I am taking x is equal to 0, I am getting force as positive. If I am taking x is equal to 2, I am getting force as negative. That means the condition have been valid. That means the given equation is nothing but an SHM equation. This equation is an SHM equation. Equation of SHM. So I think you know how to validate the equation of SHM. So now how in this way you can do the validation of equation of SHM. So now let us go with a few more things in the SHM. Before going that, let's go with the terminology of SHM. Terminology of SHM. If I'm talking about terminology of SHM, how we can do, what we can talk is first of all, let us analyze the picture of SHM. This is mean position. This is positive extreme. This is negative extreme. See better. This is positive extreme. This is negative. Sorry, this is positive extreme. This is negative extreme. Sorry. This is mean position. This is positive extreme. This is negative extreme. Negative extreme means in the left direction. Positive extreme means in the rightward direction. So the distance from mean position to positive extreme is nothing but amplitude plus A, and this is going to be negative A. Negative A. So amplitude, this is nothing but amplitude. So amplitude will be always constant. If it is amplitude is 3 meter, 3 centimeter, then this one is also 3 centimeter. But why I am taking minus? Because in order to indicate the direction. So let me go with the terminology of SHM. Just a second. Okay. Now see, the first one which I am going to discuss is mean position. I have already discussed with you people mean position. What is mean position? If I am talking about mean position, if f net is equal to 0, if f net is equal to 0 at a position, such a position is known as Now I am talking about amplitude. What is meant by amplitude? The maximum distance traveled by the particle from mean position. So see, this is the maximum distance from here to here. So amplitude, the maximum distance from mean position to positive extreme, or positive amplitude mean position to negative extreme, we call it as amplitude. Then the next one is time period. What is meant by time period? The time taken to complete one cycle. The time taken to complete one cycle. One cycle means what? One cycle means initially body starts from positive extreme mean position to positive extreme to mean position to negative extreme, negative extreme to mean position. This is something called as one cycle. One cycle. That means how much time it have been spent to cover this much amount of motion, that such a time is known as time period. It is denoted by capital T. Now the next one is frequency. So what is meant by frequency? Frequency, number of cycles, number of cycles per 1 second, per 1 second. That means in one time period we are having one cycle. Now in 1 second, let's call x cycles. So how to find x? Cross multiply. So x into t is equal to 1 into 1. So x is equal to 1 by t. This x is called as frequency. Frequency will be denoted by n. Some people will be denoted by n. Some people will be denoted by f. So n is equal to, or f is equal to 1 by t. In some books it will be denoted as n. In some books it will be denoted as f. You don't want to worry about these things because it is just a thing which is used to remember the things. So frequency is equal to 1 by t. So this is all about terminology of SHM. So this is all about terminology which is given in SHM, and the most important thing is in one time period, note, in one time period the distance covered by the particle is particle is 4a, 4 times of amplitude. Why? Because mean position to positive extreme a, again positive extreme to mean position a, again from mean position to negative extreme a, again from negative extreme to mean position a. So 4a, so 4a, 4 times of amplitude. Okay, so very important point. So up to now what we have done is we have talking about the terminology of SHM. In that we have talking about mean position, amplitude, time period, frequency, and what is the distance covered by the particle in one time period. So these are the things which we have studied by up to now. Now let me go with the discussion of analysis of SHM. Now I am going with the analysis of SHM. So analysis of SHM. So let me go with the analysis of SHM first of all. This is mean position. This is positive extreme. This is the negative extreme. This is mean position. This is positive extreme. This is mean, negative extreme. This distance is plus A. This distance is negative A. This is A. This is minus A. This is mean position. This is positive extreme. This is negative extreme. So at positive extreme, F net is going to be what? So F net is going to be 0. Sorry, at mean position F net is equal to 0. If F net is equal to 0, that means A net is going to be 0. The net acceleration at mean position is going to be 0. Now, what is about positive extreme? So here positive extreme is F net is equal to minus of kx. But here x is, F net is equal to minus of kx. But here the x will become a maximum, so it will become amplitude. So here F net is going to be maximum, but it is acting in which direction? So it is acting in this direction, because when the body is moving in this direction, force will act in this direction. So F net is going to be maximum, but it is in the opposite direction, so A net is also going to be maximum, and A net is also acting in the same direction. And if I'm going with the negative extreme also, it will be again maximum, but it will act in this direction. A net and F net are acting in this direction. So here again F net is going to be maximum, and A net is again going to be maximum. But here, if I'm talking about here, velocity is equal to maximum. I have already said you, whenever F net is equal to 0, only acceleration is 0. It does not mean velocity is also 0. Velocity can be something. Okay, so velocity will be maximum, and here the velocity is going to be 0. You can ask why velocity will be 0 here. The reason is, for example, if I am throwing an object in the upward direction, and if I am seeing the things at the maximum height, then the body starts moving in the downward direction. That means the body starts moving in the downward direction means at the maximum position, maximum height, velocity is going to be 0. In the same way, if it reaches here and it takes back its position, if it is coming back in the direction, it is coming in this direction, then what it means, at this position the velocity should be 0. And in the same way here also the same thing will happen. When it reverses back its direction, then velocity is going to be 0. So at this condition, velocity is going to be 0. At this position, the velocity is again 0. At this position, the velocity is maximum. Velocity is maximum. So this is all about analysis of SHM. So in 1 second, let me brief it. At mean position, F net is going to be 0, A net is going to be 0, velocity is going to be maximum. At positive extreme, F net is going to be maximum, A net is going to be maximum, velocity is going to be 0. In the same way, at negative extreme, F net is going to be maximum, A net is going to be maximum, velocity is going to be 0. So you should always look after the directions also, and the most important thing is when F net is equal to 0, only A net is going to be 0. It does not mean velocity is also equal to 0. So I think so you understand the concept of terminology of SHM, analysis of SHM. Now let me go with the discussion of equations of SHM. So let me go on the discussion of equation of SHM. Equation of SHM. Very interesting. Only the thing is, always physics is such a subject you should understand the things. Without understanding, we can't do anything in the physics. Once if you understand the concept, then you can do the application part. And physics understanding is one part and application is one part. Both are important. Without understanding, we can't go with application. But without application, there is no use of physics. Okay, so both are important. So let us go with the equation of SHM. In equation of SHM, what we will do is we can frame many equations. One is according to velocity, one is according to acceleration, one is according to displacement. We can have many equations. So let us frame each and every equation. Let us understand each and every equation. Then we can go with the problems on regarding the equation of SHM. Okay, so let me start. The basic equation of SHM is f is equal to minus of kx, where k is called a simple harmonic constant. So you know that f is equal to nothing but according to Newton's second law of A, so it is nothing but minus of kx. So A is equal to, from this, what I can write is minus of k by m into x. This term k by m, we call it as omega square. So why sir? Where omega is called as angular frequency, angular frequency. Why I am taking, within a few seconds I will explain, not right now, because the concept should be taught. This will be understand only when you go with the other equations also. So k by m is called as minus omega square. So let us go with the discussion of the thing will become a is equal to minus of omega square x is the equation 1. This is our equation 1. So let us go with the second equation, and you can also call it as acceleration is nothing but dou square x by dou t square. If you bring minus omega square here, this is omega square x is equal to 0. This is called as a differential equation of SHM. The same thing, but in terms of differential form. So it is a differential equation of SHM. Differential form of equation of differential equation of SHM. So any equation which have been which is satisfying this condition, that is nothing but equation of that equation is known as the equation of SHM. So once a question have been asked regarding this one in the NEET, it is very simple. That is dou square x by dou t square plus 5x is equal to 0. Find omega. If someone asks like this, so compare these two equations. From this, omega square is nothing but equal to 5. If you compare, so omega is nothing but root 5. So it is very simple. This is asked in the NEET examination. Very simple question. The only thing which you should know is you should know what is differential equation of SHM. And once if the comparison have been done, then you will get omega is equal to root 5. So this is all about a question regarding NEET. Then let me go with the second equation, that is regarding velocity. So you know velocity is equal to acceleration is equal to minus of omega square x. So what you can write is acceleration is equal to nothing but dv by dt. Change in velocity by change in time. So acceleration can be also written as a dv by, I'm multiplying and dividing by dx into dx by dt. Because dx get cancelled out, so I am not changing the any significance of the equation. So what is dx by dt? Dx by dt is nothing but velocity. So acceleration is equal to v into dv by dx. So if I am taking this equation here, so v into dv by dx is equal to minus of omega square x. Integrate on both sides. When I am at mean position, my velocity is going to be 0. And I am at when I'm saying it, when I'm at mean position, velocity is maximum. So let's call v. and when I am at positive extreme velocity is 0. Let's call the mean position as x. The most important point is it is not necessary that mean position should be always 0. Mean position can be something. For example, if I am taking this one, x is equal to 1 is my mean position. So in this direction, if I move 2 distance, if I call this one as 2 amplitude, then this one will become 3. And in the same way here, 0 minus 1 will be the amplitude. It is not necessary that mean position should be always 0. It can be anything. So let's call the mean position as x. The maximum amplitude is a. So if I am differentiating, so what I can do here, sorry, this is dx I can send here. So v dv, that is from v to 0, is equal to integration of x to a, that is omega square x dx, because I am sending dx here. So let us go with the solving of the equation. So it will become v square by 2. That is from, I think so, you are familiar with the integration formulas. Is equal to minus of omega square into x square by 2. That is from x to a. So this one will become v square by 2 is equal to, or you can directly cancel out here 2 and 2. So this is v square minus of v square. So first because 0 will come, next v will come, is equal to minus of omega square into a square minus of x square. Minus minus get cancelled out. So v is equal to plus or minus omega into root over a square minus x square. This is equation 2. Plus and minus indicate the direction. So equation 2. This is the equation 2. This is equation 2. So velocity is equal to plus or minus omega into root over a square minus x square. So when x is equal to 0, then velocity will become a omega, which is nothing but maximum, velocity. That is at which position? Maximum velocity. That is at which position? That is at mean position. So v is equal to a omega will be nothing but what? V is equal to a omega is the maximum velocity at mean position meter. So you can take like this. So now let me go with the discussion of equation of a system regarding displacement. So now let me go with the discussion of acceleration. So sir, we know v is equal to plus or minus. Plus or minus I am not taking into consideration because it indicates direction. Velocity is equal to root of a square minus of x square. So velocity is nothing but dx by dt. So dx by dt is equal to omega into root over a square minus x square. So what you will do is dx by root of a square minus x square is equal to omega into dt, So integrate on both sides. So what happens is, integration of dx by root of a square minus x square will become sine inverse x by a. This is the formula regarding integration. So if you see this formula and if you compare with this one, then it will become sine inverse. So let me go with the 0 to t. Initially my time is 0, final time is t. Initially my position is x initial. This is for final, x final. So sine inverse, this one will become x by a. That is from x initial to x final. That is from omega t, because integration of omega dt, omega is a constant term, integration of dt will become t, and 0 to t, so t minus 0, it will become omega t. I think you are very familiar with the integration part. So sine inverse x final by a minus sine inverse x initial by a is equal to omega t. So this is called as sine inverse of x final divided by a is equal to omega t plus sine inverse x initial by t. X initial by t. This term I will simplify final. So x final divided by a is called as sine of, if I am taking sine here, omega t plus this total term I am taking as phi naught. What is phi naught? Phi naught is called as initial phase. Initial phase. What is meant by initial phase? Initial phase is nothing but where particle rise initially. Initially, what is the position of the particle? So plus phi naught. So x final, that is x is equal to x final. Can I take x? So if I'm taking x, basic general in general, so omega t plus phi naught. So x is equal to a sine omega t plus phi naught is the equation of what? SHM. So this is my equation 3. So these are the three most important equations. Regarding these things, you can also solve problems. So if some other equations are there, those equations are again from here you can differentiate once again this equation 3. So dx by dt is equal to a sine omega t plus phi naught. So dx by dt is nothing but, sorry, d by dt of. So dx by dt is nothing but velocity. Velocity is nothing but a is a constant term. Cos will be the sine integration with differentiation will become cos omega t plus phi naught into omega t. Internal differentiation is omega. You are very familiar with the integration and differentiation part, I hope. So a omega cos omega t plus phi naught is the equation of velocity. Let's call this is equation 4. Now again differentiate again this equation. So dAv by dt is equal to d by dt of a omega cos omega t plus phi naught. So this one will become acceleration. Acceleration is equal to a omega is a constant term. Differentiation of cos will become sine omega t plus phi naught. And again it is a differentiation of omega t is nothing but omega. So it will become omega square with symbol minus, because cos omega t plus phi naught will become nothing but minus of sine omega t plus phi naught. So this is equation 5. In the starting I have explained you, sir, why I have taken k by m as omega, because a is equal to nothing but, see, if I am comparing fifth equation and third equation once again, then what I can take is a is equal to minus of omega square x. If I am comparing fifth equation with respect to third equation, so because a sin omega t plus phi naught is nothing but x. A sin omega t plus phi naught is nothing but x. So substituting it, I will get a is equal to minus of omega square x. But in the starting condition, I get a is equal to minus of k by m into x. So if I compare these two equations, then I will get k by m is nothing but omega square, which is nothing but what's the frequency. Angular omega is nothing but angular frequency. So this is the way how you can frame the equations of SHM. So I am writing all the equations of SHM at the same place. So first equation is a is equal to minus of omega square x, which we have derived. Then b is equal to minus of plus or minus omega into root over a square minus x square. Then we have written x is equal to a sine omega t plus phi naught, or we have done, these are the things which will give you magnitude, or in terms of which will give you in terms of magnitude return. So next, in terms of phase angle, if I want to write, then velocity is equal to Velocity is equal to what? Velocity is equal to a omega cos omega t plus phi naught, and acceleration is equal to minus of a omega square sin omega t plus phi naught. These are the equations which are in terms of phase angle. These are the things which are in terms of phase angle. And the most important thing is this sin omega t plus pi naught will give you total phase. Total phase means where the finally particle rise. Total phase means where finally the particle rise. Finally particle is held. So these are the ways how we can derive the equations of SHM. So on this we can have few problems. So that we will do it in the next class. Thank you students. Thank you very much. Hope you understand. Hope you enjoyed the class very much. Thank you very much. Thank you everyone.